All right, the topic for section 210 is rational inequalities. All right, so last time we did polynomial inequalities, so now we're going to look at rational inequalities. And so we're going to use the same approach to solve these inequalities as we did the polynomial inequalities. We're going to do it by graphing. And so here is one of the main points to keep in mind while we are solving rational inequalities. So we have a function, a rational function graphed here at the right. And so again, by graphing, we want to notice on which intervals the function is positive and negative. All right? Now, here's the deal. A polynomial function can only change signs at its real zeros, right? And so that's what we were concerned about, would be the real zeros. However, a rational function can change signs at its real zeros or at its points of discontinuity. And so for this reason, when you solve a rational inequality, you must include the zeros of the numerator and the denominator, because the zeros of the denominator will be points of discontinuity. All right? So, what we need to make sure that we consider when we are solving this is from the graph, okay, we need to consider the points that are just the zeros, all right, but also the points of discontinuity where these vertical asymptotes happen. And they will happen at the zeros in the denominator. So that's how we can come up with that value. Let's graph the first one, see how it looks. Y equals, all right, so I'm going to press divide. That'll give me a fraction. And that's going to be 4 on top. And on the bottom, I've got x minus 6. All right, so I'm going to come out here, and it is plus. And I need another fraction. So we'll get 2 on the top and click down to the bottom. Oh, man, what am I doing here, man? This is, there we go, finally got it. Clicked on the right spot there. So that'll be x plus 1. All right, so here's my graph. Okay, so now, remember, what we're looking for is we're looking for the parts of the graph or the intervals where this function is greater than 0, strictly greater than 0. Now I can see that it hits 0 there, right? And so we'll call that 4/3 when we write it in. But the question is, all right, so where does this interval start? Okay, so again, you've got a vertical asymptote here, and the long way of doing it is just trying to trace this graph up and try to estimate where that limit is, right? But there's a much easier way of doing it. All right, so it appears to be at -1, and we can confirm that it is at -1 because if I plug in -1, that gives me a 0 in the denominator, and then so that's where your vertical asymptote is going to appear. Okay, so we do know that that vertical asymptote is going to be at -1. So in essence, that's where that interval is going to start. So it's going to start at -1, not including -1, because that's where your 0 in the denominator would be, right? And algebraically speaking, if you were going to put these together, remember you would have to multiply the top and the bottom by x plus 1 times x minus 6, and 1 would cancel there, and then you would get a common denominator, and then you could add them together into one deal. So that's where your zeros would be coming from. All right, so let's open this back up, continue to take a look here. All right, and now how long does it continue? Well, it continues till 1.333. We'll write that more exact as 4/3. And you can probably find like a fraction, a decimal to fraction converter estimator deal somewhere online if you need that. And of course, does it include this 4/3? No, because we want strictly greater than, so I'm going to use a parentheses. I need to union that now with another interval because it is positive again over here. Well, the question is, what value does the interval begin at? Well, once again, if I use my other denominator here, then we know that that would be at 6. And once again, like I explained earlier, you might say, well, Coach, well, if I just put 6 in there, then it looks like that part would be 0, but the whole thing wouldn't. But remember, if you put them together as one expression, you got to get a common denominator first, and then in your denominator, it would be x minus 6 times x plus 1, and then that's where the 0 would actually come in once you combine those together. All right, let me see here. And still, even at that, you're still dividing by 0 here. which would give you an undefined operation in the middle of the thing. All right, so again, division by 0 or points of discontinuity. Okay, all right, so let me see here. What's this other point? So that would be at 6, and so the other interval where it is positive would be from 6 to positive infinity, not including 6. Okay, so like I say, graphing by far is the easiest way to come up with the solutions to these. We have several more that we want to try here. And so with this one, first of all, you need to make sure one side is set equal to 0. If it's not, you have some rearranging to do. X plus 6 over 4x minus 3. Move that over, change that to minus 1. And then now I can set that to greater than or equal to 0 on one side. Now I'm ready to graph it. So let's go in here and let's take that one off. And I can go ahead and make that minus 1 there. Let me set that down so you can see. And on the top here, I want to go with x plus 6. And on the bottom here, I want to go with 4x minus 3. 4x minus 3. And so now we can begin to look at where this thing is greater than or equal to 0. Now, I want to figure out where this vertical asymptote is. And so it doesn't turn out to be an integer number this time, but I can figure it out by solving 4x minus 3. I want to figure out where that's equal to 0. Well, if I go 4x is equal to 3 and then divide by 4, then we can see pretty quickly that x is equal to 3 over 4. And so that would be the place of the vertical asymptote. And so that would be the place where the interval starts at 3/4. So that'd be 3 over 4. All right, so that's where it starts. Now, I want strictly greater than or equal to 0. So the place where it crosses here, the 0 there is 3. And so I know that's the ending of my interval. And I am going to put that in a set of brackets because 3 does count as a part of the solution because equal to 0 is okay. Is there any other portion where it's greater than or even equal to 0 on the graph? There is not. We're done. All right? Next one. Okay, so for this one, I've got to move the 3 over to the other side. And when I do, it'll be x squared minus x minus 11 over x minus 2 minus 3 less than or equal to 0. So first step, get it set equal to 0 on one side. And so from here now, I need to change the top of my fraction to x squared minus x minus 11. And I need to change the bottom of my fraction now to x minus 2. And I need to come out here and I need to go minus 3. All right. So once again, when I take a look at this, I need to try and figure out, number one, where my intervals are going to be where it's less than or equal to 0. Well, the first one that I can see here would start from negative infinity. And where would it go to? Well, it would go up to this point, which is at negative 1. Equal to is okay, so I'm going to put that negative 1 in a bracket. Okay? Now I'm going to union that with another interval because there's another place where it becomes, once again, less than or equal to 0. And that's going to be from wherever this asymptote is, right? It's hard to tell by the graph. Okay? But we can tell because it would be the place where the denominator here is 0. Well, that would be at positive 2. And so that's going to be now from positive 2 over to 5. Positive 2 to 5. And 5 is included in the value because that's at 0. However, 2 is not. Well, why not? Well, it doesn't hit 0 at 2. That's where the asymptote is. Okay? So 2 is not going to be a part of the value of the solution. So it gets a parentheses. 5 is a place where the graph hits it at 0. And since 0 is included in my inequality, we're going to put that in a bracket. All right? So that's how that works. One more that we need to try here. That'll be the last one. Okay, so on this one, remember you need everything going to one side and set it equal to 0. So I'll go 1 over x minus 1 over x plus 5, and then that's going to be greater than 0. Greater than 0. Okay? All right, let's graph it. So we'll come over here, and we will take off what we don't need there, and so that we can change it. And so I'm going to go with 1 over x here. Then it's minus, and I need myself another fraction. So that's going to be 1 over x plus 5. And so here is my graph. And I want to know where this is going to be strictly greater than 0. Greater than 0. Well, coming from this side of the graph, I can see that it's going to start at negative infinity. And so question is, where does it stop? Well, here at this 0, that where the undefined portion here would be at negative 5. So I'm going to put a negative 5 here. Now remember, it doesn't get a bracket because at that value, that's where the asymptote is. That's going to be union with another interval now where it's greater than 0. And that's going to start from 0 is my other asymptote because of this denominator. So it's going to start at 0, of course with a open parentheses, not a bracket, and that's going to go all the way up to infinity. Okay, so there you go. Now, by the way, I need to mention this too. Some people might be saying, well, Coach, what if I took this expression and moved it over here instead of moving this one over there? How would that change things? Well, it wouldn't, because if we did that, the only thing that would change is that this would become a positive and this would become a negative, right? And so, again, once that happens, though, it just flips the graph, right? It flips the graph, but guess what? If you move that over to this side, then you would be looking for the places where this is less than 0 instead of greater than 0. So yes, the graph flips, but also what you're looking for also flips, so it would actually still be the same intervals. If you flip it, okay, the intervals that were greater than 0 at first flip and now become less than 0 if you moved it the other way. So to answer the question, does it matter which side you move all your terms to? The answer to that question is no, as long as you recognize your inequality sign correctly. So from here it'd be greater than 0, but from this side it would be less than 0. All right, and it still works out to the same answer, so that would not affect your answer. And this lesson is now done.